Good to go? Cool. Good morning. My name is Luke. I work for Redify. We do a lot of things, probably most well known for bespoke app creation. I'm one of the consultants, so I spend a lot of my time either writing software or talking to people about writing software. But in the case of this particular session, I'll be telling a few war stories about mainly one particular HoloLens engagement. I've done a few over the time period, but I think this one is probably the one that's probably most notable in terms of the audience and the people involved and the processes and so forth. So it won't just be technical. I will be talking about other things, but certainly from a developer focus. A few disclaimers. I will be mentioning companies by name. I might be mentioning products. Not so much for the people in the room, but for anyone viewing this online. This does not mean that I have some insider knowledge, some corporate association. My views are my own. And yes, don't mistake them for some official corporate line. Not that lawyers aren't wonderful, wonderful people. Okay, the other thing is, this is a talk about 3D. Anyone who is particularly susceptible to motion sickness, feel free to close your eyes. I won't take it personally. If you suffer from neck injuries and any of those kind of normal roller coaster complaints or pregnancy, then just hold your seat a little tighter, I suppose. If you happen to come across those things during this talk, I'm sure NDC will be very interested to hear your evaluation form on how that happened. Okay, so let's get started. Right. Yes, we are actually in 3D. Okay, I accidentally discovered recently the most distracting visuals ever for a talk. So I'm trying to go a little more minimalist these days, because otherwise you just have people kind of staring wide-eyed at the screen and completely ignoring what the presenter is saying. So yes, we do have the advantage of 3D, but I'll try and keep it only mildly distracting. Okay, so this is all about a project that I was involved with around November, December of last year. A group of us met up in Seattle, Washington at Microsoft to produce a HoloLens app. There was representatives from Microsoft, from Telstra, from Redify and Cloud, which are both Telstra companies, from JumpGate VR, who do 3D modeling and other such things, and from Qantas. And I won't go into the specifics of the commercials about what the app was doing and who funded and how it came to be. The problem that we're focusing on is actually producing this app. Now, the two qualities that this app needed to have was it needed to be stable, i.e. it needs to run for an entire day without crashing, and it needs to be not so much exciting, but makes people go, ooh, wow, that's kind of cool. And mixing those two things together is not always the easiest thing to do, particularly in this time frame of about 6 weeks. So what we did is spent our time at Microsoft. Microsoft has a vast number of little departments within the business. And one of those departments, or one of those groups, called Launch Vector Labs, is one of their, essentially, it's like a game development studio, except they, at this particular moment in time, are focused on HoloLens-related applications. They spend their time helping customers create HoloLens apps. And that's the role that they were playing here. In total, I think there were about between a dozen, maybe up to 20 of us on the project over the course of those 6 weeks. And one of probably the more interesting things at least from a regular applications development perspective, is the overall methodology that was used to create the app. So in, let's call it regular application development world, as a developer, if we were using a race car analogy, it feels kind of like we're the drivers. The team is obviously there. It's obviously takes a team to actually develop software, to launch a product. But as a developer, you're the one who's actually hitting, writing code and hitting compile and actually producing an executable. So if in Formula One, it's like you're actually on the racetrack. Everyone else is obviously playing their part, but you're, in the spotlight. The kind of feels like king of the hill, even if it is a team sport. With games development, the model is a little different. If you go into any, particularly the big game studios, you'll find the people who actually hit compile, the people who are actually producing the executable, are not the developers. They're the designers. So the way that things come together, games come together, is a little different. You still have developers, except in the games development world, they tend to be referred to as engineers. You have artists, you have all the usual people that might show up, but it is designers especially, and to approximately the same extent, artists who are in there using a tool set to produce an executable, and the developers are around the edges facilitating that process to make sure that it all goes as smoothly as possible, to make sure that designers who are on the critical path can do what they need to do. So for this particular project, we were basically treating it like a games development project. It was a very design-focused activity. I would make the case that that should probably be always the way that we tackle software development, or at least kind of 80–90% of it. If your software is dealing with humans, then having a kind of very human-centric approach to designing software sounds like a good idea to me, but I don't get to make these choices, so there we go. Okay, one thing that I will note throughout this talk is feel free to stick your hand up and ask me questions as we go along. Most of the heavier duty stuff is down the tail end of the talk, so you'll either get an answer from me saying I don't know, or me telling you that I may actually cover it a little later. Okay, so this, where are we? This is a very, very dark screen. I cannot see a thing. This is not something I accounted for. Let me go Alt. Okay, we'll try that one again so that I can find my way. Okay, here we go. The demo gods are obviously with me today, and highlighting that I am not in. Okay, finding my way. There we go. Okay, so the tool that is used with HoloLens development is Unity 3D. It's not the only tool that you use or could use. Microsoft, strictly speaking, in order to deal with, for any application to deal with a HoloLens unit, really just requires that you use a tiny little SDK so that your application can receive the live data feed of where someone's head is. Everything else is pretty standard. In fact, you'll find when you create an app for the HoloLens, it's just a UWP app, like a Windows Store app. The only thing that makes a HoloLens app any different to a regular app is, yes, this stream of 3D data about the user's head position. The reason why Unity 3D is used as opposed to Visual Studio is because Unity 3D inherently is designed for dealing with 3D things and for dealing with high-end multimedia. So it's a good fit. Yes, if you were really enthusiastic, you could certainly handcraft your own UWP app just using that SDK and produce results. There's nothing stopping you running regular UWP apps in HoloLens, and they come up as 2D windows in a 3D space, but that's kind of boring. Okay, so Unity 3D, for anyone who hasn't seen it, is basically just a design space. You can drag and drop 3D meshes, you can grab textures, apply them to those meshes, you can get sounds, and you can script everything up in the scripting language of choice for Unity, which is C#. You are able to do pretty much all the same tricks that you might want to do with C# in a WinForms or UWP app or any other sort of environment. So it can feel all very, very familiar if you wanted to, but at the end of the day, it is just being used as a scripting language. So sometimes the performance characteristics are not what you might expect. One of the big things that is different for Unity 3D apps and games development in general is expectations around the wider life cycle of your application. So hands up anyone who has worked on version 2 of an app, like where you've taken version 1's code base and manipulated it, added features, so you get version 2, yep, at least one of us. Hands up anyone who's worked on an application that is more than, say, 12 months old. Hopefully that, yep, cool. Well, in the world of games development, that is not as common as what you might think. So if you imagine, a big title such as, I don't know, let's pick on Halo. Halo 2, 3, 4, whatever. Halo gets worked on for, say, 3 years, active development. During that time, they stick rigidly to their particular version of, well, they don't use Unity 3D, but let's pretend they did use Unity 3D. They stick rigidly to that particular version of Unity 3D. They've got all their other tools. They stick to those versions. They produce that particular version of Halo 3, and they ship it. And it gets released to the public. Everyone loves it. They might do some fixes, and then basically they never touch that code base again. It gets archived off. They might produce Halo 4 in another year or two, but there's a good chance that they're never actually going back to that Halo 3 code base. Every time, it's kind of like movies. Just because there's a Jaws 3 doesn't mean that they used anything from Jaws 1 or 2. A completely different setup each and every time. They might use similar tool sets, but yeah, it's essentially a new project every time. What that means is when you're dealing with middleware or pretty much anything related to the games industry, backwards compatibility, at least in terms of the software development process, tends to drop way down the priority list, because the reality is that most game developers kind of care about it for about 3 to 6 months worth of bug fixes at most, and then never touch those code bases again. So if you're coming from particularly an enterprise space where these applications, I've worked on an application that had an active lifespan of 30 plus years, which was older than me at that particular time. I can guarantee that there are very, very few games that get anywhere near that in terms of being actively worked on. And they're certainly not being actively worked on using middleware like Unity 3D. They're kind of handcrafted little bits of goodness. So yes, the first big lesson out of developing for things like the HoloLens, using game creations like Unity 3D or Unreal, or even just your own hand-rolled things, is that the industry that's supplying those tools is not that friendly to really long-term maintenance or continued expansion. It wasn't a case on this because this was a version 1 sort of project, but I've literally just finished up a project just recently where version 1 of this particular product was developed middle of last year, and by the time we came around to revisit it to add some extra features, to do some polishing 7 months later, the cost of reopening that in a new version of Unity and the third-party libraries was not insignificant. That was a mildly painful process. In the case of this project's only points of pain were the build process. Microsoft, not surprisingly, has some CI/CD involved wherever possible, and that build process just needed some tuning to get it up to date with whatever the latest version of Unity was at the time, and so forth. The other point of pain was pretty much any third-party libraries, and by third-party I basically mean anything that wasn't written by Unity. In this case, the Microsoft Mixed Reality Toolkit, which is an open source project that you can find on GitHub, it required some tweaking, some changes just to get it up to par with the latest version. So yes, in this particular project, didn't cost us too much time, but certainly something to be aware of if you are developing, once again, anything that relies upon games industry technology. Okay. So, as hinted at by the mention of Qantas before, this HoloLens app was related to the aircraft business, and it because it's a HoloLens app, there's a strong focus on the interaction between the real world and the virtual, having holograms interact with the real world. Our chosen point of interaction with the real world in this case was via this diorama, and I'll show you a little bit of what that diorama looked like a little later, but suffice it to say, it involved 2 pieces of aircraft fuselage. Cutting up aeroplanes is a bit of an expensive business, even for the likes of Qantas. So one of Qantas's workshops was nice enough to craft us up some fake fuselage parts. And if you think you get some weird stares at security for dragging your computer through the X-ray machine, try dragging fake aircraft onto an aircraft. It's a weird experience. Okay, so there we go. I found how to there's an aircraft hiding in all of that, I promise. The other thing that we had in this HoloLens app was an aeroplane. And this aeroplane was a virtual aeroplane, and it basically came in 2 sizes. The first was a small aeroplane, and this small aeroplane was used during the intro, and it would come down and basically land on the desk portion of this diorama. And I remember when that was first proposed by the lead designer, and I was going, really? Sounds a little cheesy. But it's surprising how engaging it is to have the virtual interact with the real world. There are lots of really useful things that technologies like HoloLens can do, but it's still at the point where it gets a wow out of people. Like cinema 100 years ago with the moving image, people go, ooh. We're at that kind of stage still with mixed reality. Having something come in and interact with the real world is still a big enough novelty where, yes, it engages. The second way that it's easy to engage with a particular HoloLens audience, but also with virtual reality audiences, is through scale. And in our case, we had scale, possibly a little too much scale. our scale was a full-sized aircraft. Now, when we were doing our research for this application, we wandered down to the Qantas engineering bays at Sydney Airport and got a chance to stroll around an A380, basically nose to tail, and they're not exactly small planes. Now, our intent was to focus up on near the rear of the aircraft, where basically not too far from where the last door is on the aircraft before you hit the tail section. If you against a real A380 or its Boeing equivalent, the 777 Dreamliner, that's like 4 stories off the ground. So we had a bit of a size problem if we were going to display one of these things in a HoloLens. We wanted this usable in a few different kind of environments, but at this rate we're going to have to restrict ourselves to purely people who are lucky enough to own their own stadium, because if you wanted to go and look at the wing, then that's a fairly decent walk for a few minutes over to look at the wing, and then a fairly decent walk all the way back, and then you've still got the problem of it's 4 stories ahead above you to see the bit that we're interested in. So obviously we required a little bit of scaling. We played around with a few different scales, and the one that seemed to work, I think from memory, was about 1/20th of the size. So what that means is this A380 is scaled down to, I think, something which is approximately the dimensions of this room. My apologies for anyone online who doesn't know the dimensions of this room, but what's that, about 10, 15 metres by 15 metres. So small enough that you can actually walk to the wingtip, and people, that's the other kind of big wow moment, is being able to, they remember that it's an interactive space and they can actually walk around this plane, and it's perfectly locked in position, so they can walk over to the wing and have a look at it. And that's, you can tell when people get to that point in the application, because a big grin comes out on their face and they go, ooh. And you have people actually get down on their hands and knees and check out the wheels and the detail in the wheels, and then try popping their head actually through the plane and having a look and seeing if there's anything inside. It's all quite fantastic. So in the case of this particular app, we settled on about 1/20th of the scale, which was small enough to get around, but big enough to still give a feeling of presence, give the feeling that you're dealing with a real aircraft. Okay. So let's see if we can find our way through. Okay. Oh, I wasn't planning on this being quite so high contrast. Navigating in the dark seems like a very first world problem. Okay. Here we go. There we go. Right. So now we get into some nitty-gritty developer level details. The way Unity tends to work is that the highest or the biggest concept in Unity 3D is the concept of a scene. So if you've ever played a computer game, you can, the equivalent of a scene is probably a level. So when people are designing levels for computer games, in Unity 3D there's a good chance that they'll have one scene per level and basically swap between scenes. And inside of that scene, you've got all the things that you might see in that scene, enemies, good guys, bad guys, landscape, all the rest of it. For each one of these scenes, Unity 3D keeps a file. If you look inside the file, it's just a text file, and it describes the relationship between everything in 3D. So this tree might be at this location, that car might be at that location, and it'll describe the coordinates of those two relative to each other. Unfortunately, things are a little more complicated in as much as that it doesn't actually say car or tree, it gives the GUID of car or tree. And if you've got a reasonably complex scene, there's like hundreds of these GUIDs, you know, GUID at this position, GUID linked to that GUID, GUID linked to that GUID. So it's this great big kind of dictionary or hash table of GUIDs and their associated properties, which is usually not a problem, but it does have a few unexpected day-to-day consequences. The big one being when you've got any more than about, I don't know, 2 or 3 people on a project. And on this particular project, we certainly had more than 2 or 3 people. My apologies. I have a disease vector into my household, aka a 5-year-old, and my body can't quite decide whether it wants to play with the latest infection which is sweeping through my household. Anyway, story at hand. So you have one file per scene, and for this particular application, we didn't really have any obvious reason to use more than one scene. The user experience is all kind of in one virtual space, and that tends to be the way with a lot of HoloLens applications. But this one was particularly so. There was just no obvious point to kind of take a cut and move stuff into another scene. So that means we had one sizable file, and if you got a team of 12, 20 people all working on this one file, then even with your best source control, you're going to find yourself in a little bit of pain. And particularly so with a source file which is only mildly human readable. It's one thing when you're just dealing with the file yourself and you can go, oh, okay, that GUID seems to be kind of related to, I think that's the tree. Okay, so it makes sense that I'm replacing the tree or updating the tree or something like that. But when you've got 20 people all mucking around with the one scene file, you pretty much hit the nexus of evil very, very quickly. And lo and behold, that's what happened to us and this team. The Microsoft team, this game studio, Launch Vector, they usually have much smaller team sizes. This one was a bit of a unique set of circumstances. So even it was while they had experienced kind of merge hell before, this was kind of 2 or 3 times their regular merge hell. So it was a bit of a unique experience for them as well. The solution to this, as you might guess, is to break that up into multiple files so that you've got an even better chance of basically one person working on their own little bit at any one time. The way that you achieve this in Unity, for the most part, is through things called prefabs. So prefabs are like a little bit of scene all by themselves. You can say, okay, this tree and that chipmunk and those nuts in the tree and so forth, I'll put them all in this little prefab, and when that gets referred to in the scene, it's just one little entry. I can go and work on that tree, and it'll go, and all the changes will go into its own file. So that solved a fair amount of the pain. It didn't kind of obliterate it completely. I still, personally, merging Unity files is not one of my strong suits, apparently. I'm just not that smart. So I still encountered a bit of merge hell, a bit of merge pain myself. But yeah, for 20 people, we went from being absolutely kind of locked in for, I don't know, hours at a time trying to resolve these things into some sort of rolling level of progress. Okay. The next problem that we faced was how to architect the flow through the application for the user, how to architect the experience for the user. So this particular application is relatively linear. It only has kind of 2 or 3 spots where users can really have a whole lot of control about how they tackle things. Most of it's pretty linear, but that still presents its own problems. So one way that we could approach this is that we could sit down and write code, and you basically kind of do the same sort of code as what you might write for some sort of wizard. So, you know, user presses next, next thing happens. User presses next, next thing happens, and so forth. And that's okay, but keep in mind the composition of this team is we've got designers taking the lead on this, artists taking the lead on this, and if every time that you know, a new section needs to be added or somehow changed, a designer has to walk over and ask a developer, can you wire this up for me, and then check it in, and then I'll work on it. That's not, you know, very productive at all. So kind of almost immediately discounted that. The other way that we could have tackled this is Unity 3D has a vast and awesomely complex animation system. If you've ever played any kind of AA or AAA games recently, you will have noticed just a tiny bit of focus on animation, people running around doing all sorts of impressive things. The amount of animation that we had in this application wasn't huge. We did have some, but Unity's animation system isn't really, well, particularly at that point in time, wasn't really focused on trying to solve that wizard problem. What we were talking about was basically stretches of us wanting to do stuff, and then user interaction, and then another stretch, and so forth and so forth. And to stretch Unity's animation system to try and have that work for us would have just led us to pain, much, much pain. If you have a look at talks from people who put together, you know, sizable games, and they talk about animation systems, there is a lot of responsibility and kind of developer hygiene style rules that are needed by the entire team to make animation even vaguely start to work. Otherwise you just end up with a great big mess of unmaintainable goop on the screen. So the solution for us came from Unity. We were lucky enough time-wise that Unity, I think it might have been literally that week or a week previously, had just released a new bit of functionality into beta testing. If memory serves, I think it's called Director. And Director, as its name might hint at, was one of the first major attempts by Unity to break out into a new market. So they had been quite successful, to say the least, with capturing game developers, and if basically anything that's not a AAA title, there's a very, very, very good chance that it's developed in Unity. So they've got a huge market share already, but their vision, you know, goes beyond creating games. And one of the big kind of secondary things that they wanted to tackle was filmmakers. So they got the likes of the director behind District 9, Ethereum, and I cannot remember his name, South African director. They got his production company to basically try and produce a series of films using Unity 3D, and they're using mocap and all sorts of, you know, full-on Hollywood level production, all going through the Unity app. And one of the things that the film people, their feedback back to Unity was, well, this is all fine, but this whole animation system is really still geared towards game developers. If I want to do a run cycle and, you know, a character leaping over a log and then continue running, the animation system works brilliantly for that. But if I've got, you know, 6 minutes of an actor strolling around a room delivering a monologue and and I need to capture the nuances of the face, and I need to be able to mix and match edits so that I can get take 2 of this actor and take 6 of that actor and have it all seamlessly work together. Unity's not really supporting me in that. So one of Unity's responses to that was this director feature. And really, director is, as its name suggests, it's just a higher level of abstraction. With director, you can basically grab a bunch of animations, stick them together on a timeline, and voila, problem solved. Now for us, we wanted to make use of director, but we also wanted to kind of break it a bit. So we didn't want one big continuous bit of non-interactive sets of animations, because then it wouldn't be an app, it would just kind of be a movie, which is perfectly good, but not what we were aiming for. So we decided upon having a bunch of directors, basically a director for each little mini, dare I say it, scene without getting too confusing. You'd have one director taking care of the introduction, and then another director taking care of whatever part 1 of the story was, and then so on and so on. And that worked reasonably well. These days, director is a lot more solid, but in those days, it was very, very much a beta product. It had its own set of quirks, and they weren't quirks in areas that you ever really wanted. So if your little stretch of animation happened to include a bit of animation that repeated right at the end, then director would kind of get a little confused, and it was a 50-50 chance whether that animation played, or it played continuously, or it played wrong, or stuff like that. So it took a whole lot of fine-tuning to make a director work the way we wanted to, and it felt kind of like black magic. Ooh, you can't have a whole number here. It's got to be a partial number here for no obvious reason. So that was a bit of an interesting experience. Okay. These days, yeah, director is a pretty solid choice for orchestrating animations. If you need animations that aren't reliant themselves on interaction with what the user's doing, then director is a very, very good choice. If you need things that are reacting to the user in real time, then Unity's traditional animation system does just fine. Okay. So here's a model of the little diorama that I was alluding to before. Unfortunately, the contrast hides a lot of the detail, but essentially we have our 2 aeroplane fuselage panels constructed out of metal, mounted on a frame with a little desk thing in the middle, and users put on their HoloLens, wander up to it, and the experience unfolds around this diorama. Because we were diorama focused and we didn't really care about the surrounding world, that allowed us to ignore one of the things that is kind of one of the big selling points of the HoloLens. The HoloLens has the kind of the big technology breakthrough that the HoloLens brings to the world is spatial mapping, recognition of that spatial mapping, and being able to recall that spatial mapping. So I can, if I use the HoloLens app the hologram app in the HoloLens, I can place a hologram on a chair, I can walk out of the room, walk out of the building, walk back into the building, back into the room, and the hologram will still be there, locked onto the chair. And that's just the hardware of the HoloLens doing kind of 99% of the magic. It's recognizing the room, it's recognizing new areas, it's making the association between new areas and old areas, and doing this continual mapping so that the software can basically say, I want to play something here. And the hardware goes, okay, fine, I'll track that all the way, and so on and so on. So That's a really, really fantastic feature, and you can use it in all sorts of interesting ways. The most obvious way is just making sure that things stay put, so that the virtual world is connected to the real world. But you can do other things, like, for example, you can have virtual objects obscured by real objects. So if I stand behind this podium, if I was virtual, I could be obscured by this podium. And and it would give a more convincing feel to it. I was working on an application just recently that involved fish swimming around the user, and we could have the fish obscured by walls and podiums and all the rest of it, and give that more realistic feel to it. That's very, very good, but it comes at a cost. As I mentioned before, a lot of the hard work is done by the hardware. So, spatial mapping is happening irrespective of whether you're taking advantage of it or not. But there's a cost of your app, drawing the bits that need to be obscured and stuff like that. There's also the cost of the additional logic that you need to embed in your app. So, if your app if your app is meant to have a virtual character sit on a couch, then you need to code in the logic to find a couch in the nearby area, and then to have it so that your character can pathfind their way to the couch, and then sit down on it. And that couch might be at different heights. The real world, there may not be a couch. So there's a whole load of complexity that suddenly comes into dealing with the real world. We've got a set diorama. So we can basically go, okay, once we've found this diorama, we don't care about anything else. We just need to make sure that we know where the diorama is. And lo and behold, that's the approach that we took. So my recommendation, at least on this point, is if you can ignore the complexity of the real world, take advantage of it. There are some applications where the real world is what you have to deal with, and so be it. But yes, if you've got any chance to remove complexity, this is yet another example of where that really pays off. So how did we keep track of the diorama? Well, the first problem is finding the diorama. We could have written some search logic in our app. So the HoloLens presents a data stream to your application, and that data stream consists of basically a bunch of points, and if you want, you can connect those points into little triangles, so you've got basically a bunch of surfaces, and you can write your own search functionality. Find me a bunch of triangles that are kind of in a vaguely flat orientation, and there's kind of another bunch of triangles in a vaguely vertical orientation that are nearby. And it's possible to do that. It just takes some time, and it takes a lot of fine tuning. It's basically the same problem that software designers who write self-driving cars tend to deal with. Identify from this cloud of dots what all of this stuff is. One of my favorite stories, which I can recommend viewing online, is from one of the people from Google talking about their efforts at self-driving cars. And he describes this car coming to a stop on a suburban street, and you have a look at the data, this point cloud, and it just looks weird. There's a little thing and a big thing kind of going in circles. I think it was something like a duck being chased around in circles by a person in a motorized wheelchair. I don't know how you write a routine, a bit of artificial intelligence that inherently knows what that scenario is before dealing with it. For our case, what we did is we took advantage of some software that already exists. The problem has already been solved, and in the case of Unity 3D, it's actually one of the easy add-ons. There's some software from a company called Vuforia, and they're certainly not the only people in the market, and what they do is image recognition and spatial tracking of recognized images. So on this little table in the middle, we put kind of easily identifiable logo Didn't matter what the logo was, as long as it was of sufficiently high contrast that it could be identified from some distance. And then we trained Vuforia to go looking for that logo. And once it's found it, it can basically say to our app, that logo, it's this distance relative to the user's head. And then we can go, oh, okay, cool. That's where our diorama is. That's the orientation of our diorama. Problem solved. And Vuforia does this very well. And yes, as I mentioned, it's one of those kind of standard bolt-ons to Unity 3D, so it's a reasonably seamless experience. That being said, there's some nuances to the problem. The handover, both from a technical standpoint and also from a user experience standpoint, is not obvious. It takes some fine-tuning. So it took the team a while to go from to fine-tune it to the point where a user could stroll up to the diorama, Vuforia would find the logo, and then it would switch across to essentially the normal HoloLens tracking because yes, as I mentioned before, HoloLens is very, very good at knowing where you are in the room and keeping track of where you are in the world. So we could rely upon that from that point forward. But yes, we just needed to tweak the interaction between Vuforia and our normal HoloLens code. Okay. Right. Oops. And my mouse has suddenly decided to start appearing. Doo-doo-doo. That's a bit of a low polygon race car. Okay. Right. The elephant in the room, the very, very slow moving elephant in the room. Let's talk about performance. So the way that games, and in fact all applications work, except as application developers, we're usually fairly removed from the problem, is that you have two significant parties. We have the CPU and the GPU. We have code running on the CPU, and that's normally the code that we care about, and we have code running on the GPU, which in the case of normal application developers is usually something supplied by one of the many frameworks that we sit on top of. So it might be supplied by Windows, it might be supplied by whatever the technical stack is, browser, something. Sitting between those, the CPU and the GPU, is a vast, vast gulf in terms of the speed and the size of these components. It's like something out of Indiana Jones, where you've got these two perilous cliffs and a terrible, terrible thin, rickety bridge between the two. And you've got things like DirectX and OpenGL that are the world's most overhyped, essentially traffic wardens for this really old rickety bridge. So the CPU goes, cool, I've got something to display on screen, and OpenGL or DirectX goes, okay, hold your horses. We just need to make sure that there's only one person on this old rickety bridge at a time going in the right direction and all the rest of it. So out there with the lollipop going start, stop. And on the other side, yes, we've got the GPU. And the GPU executes code, just like the CPU, but it has some different performance characteristics. You can imagine the CPU kind of like being a small group of boffins. They are really, really good. They can take on new challenges all the time. They can adapt. They can do amazing things. But there's only a small number of them. So the amount of stuff that they can actually do at any one time is pretty constrained. The GPU, on the other hand, is a very, very different beast indeed. That is like basically a giant hall of idiots. These idiots, not the smartest, but they do have advantage in numbers. If you've got 100 idiots, even though they're all complete idiots, if they each do the same very, very simple job, you are getting through a lot of work. So that's kind of like the GPU. The GPU does a lot of stuff in an impressive amount of time, but it doesn't react well to unforeseen circumstances. It's pretty kind of locked into how it tackles problems. This makes from some interesting situations. For anyone who finds themselves writing custom shaders, and in the case of things like HoloLens app, the reason why you might want to write a custom shader, and by shader I mean the software that you write for a GPU, the reason why you might want to write your own code for the GPU as opposed to letting a framework deal with it is when you want special effects, and special effects that don't come out of the box. So in the case of this project, our special effects were, we had a few instances where we have things appearing, and the way that they appear is very Tron or Star Trek-esque, where a kind of grid appears and then the objects resolve and then the grid disappears. It's all very, it's a homage to fine sci-fi. So for those special effects, we wrote custom shaders, and it sounds a whole lot more impressive than what it actually is. It's just like any other piece of code. You discover it's kind of the way that it works, and you write the code, and voila, you produce something. The advantage with shaders is that it's one of those things where you can show your family and they go, ooh, we have no idea what you're doing, but that looks cool, as opposed to a lot of the kind of enterprise stuff where you try and explain it to your family and they go, nope, no idea what you're talking about. Okay, so the golden rule with writing custom shaders is to avoid if conditions. Did I mention that GPUs were kind of like a bunch of idiots? Well, idiots don't deal well with unexpected circumstances like if conditions resolving themselves in different ways. And writing code that doesn't involve if conditions is kind of an interesting prospect. And you might actually think that it's kind of impossible, but it's not. You just need to tackle it a slightly different way. So in regular code, you might write, if A equals 1, then B equals 2, or B equals 0. If you're doing that without an if condition, you might actually multiply the result of A with B. So if A equals 0, then B multiplied with A becomes 0, and problem solved. And you kind of multiply your way in and out of bits of functionality, and you're achieving the same effect, just with a way that doesn't scare our humble collection of uninspired thinkers that is the GPU. Microsoft, as I mentioned before, has an open source toolkit called the Mixed Reality Toolkit that supplies a whole bunch of shaders out of the box that are specifically designed to work well with environments like the HoloLens. So the HoloLens, at the end of the day, is a mobile computing device. Unlike a virtual reality system that's tethered to a PC and can rely upon the PC to do all the heavy lifting, the HoloLens is a self-contained unit. GPU, CPU, everything that it needs to do essentially normally has to be in the HoloLens itself. The Mixed Reality Toolkit has shaders which are essentially tuned to take advantage of the particular quirks of a mobile computing device like the HoloLens. Feel free to tap me on the shoulder if you want the specifics of that a little later on. From a higher level perspective, the thing that really can kill performance on a HoloLens app is transparency. And how much time do I have to describe transparency? 5 minutes, cool. Okay, so we all know what a transparent thing is? Okay, so in the virtual world, drawing transparent things is really, really costly. It's surprisingly costly. Opaque objects are really, really easy. If you're painting a picture of me, it's really, really simple. You can take two approaches. If you wanted to do it in a badly performing way, you'd paint the background first, then you'd paint the midground, and then you'd paint me. If you want to do it in a really high performance way, you'd try from the front first. You'd paint me, and then only paint the bits around me that weren't covered by me in my curve. And that would be more performant. Transparent objects are really painful because you have to paint everything that's behind a window before you paint the window itself. There's just no way that you can get around it. If it was a perfectly clear window, then you might have some options. But if it's got tint or distortion or something like that, then you're basically stuck with having to work out what's behind the window first. So what this means in terms of the graphics pipeline is the GPU needs to render all the opaque stuff and then come back and essentially work over all the same pixels again to draw the semi-transparent or the transparent stuff on top. So very, very expensive. If you want to kill well, it doesn't apply to HoloLens apps alone, but if you want to kill any sort of performance rendering, transparency is a really, really quick and easy way to do it. So We were lucky enough in this particular application not to have to deal with any transparency from memory. But I've certainly worked on other HoloLens applications where, unfortunately, the nature of the problem is it's, every second thing is transparent, and it's a really, really tough problem to solve. And there's no kind of easy wins, unfortunately. The other thing is essentially the number of pixels that need to be drawn on screen, which was one of the problems that we faced in this application. If you're standing next to a great big plane, there's a good chance the plane is going to be taking up all of your vision, which means pretty much all the pixels that you can see are going to be drawn. And that is an expensive thing to do on a mobile computing device. On a desktop, doesn't matter. You can draw seemingly half the world before a desktop GPU even starts to worry about things. On a mobile GPU, very different story. So if you want to try and, once again, keep things as performant as possible, the more chances that you get to keep things away from the user or small, the better things will be. OK, what have I got? I've got a few more minutes, and I'll use this time to deal with one other thing. So we produced this, this app, and almost had it. Nope, not going to play ball. That's OK. So 6 weeks were up. We produced this app, and we want to show it to people. So given the choice, we really, really want people to experience this on a HoloLens, which is why I don't bother showing the app on a screen, because I don't know whether any of you have seen actual recorded footage of a person using a HoloLens app, but it's really, really, really shaky. And it's a beautiful testament to how wonderful the human visual cortex system is, because it's taking some very, very shaky footage and transforming it into something that doesn't make you just violently motion sick, on the ground in a fetal position almost immediately with how jerky and nasty it is. HoloLens footage from the unit itself is terrible. And it's nothing. It's not it's not the HoloLens's fault. It's just that you've got the giant wobbly head human thing underneath, making footage very, very difficult to capture. And the purpose of the HoloLens is not to make beautiful footage for someone else. It's to provide a wonderful experience for the user. So when you see footage from Microsoft and any other vendors of virtual reality or anything else, you'll notice suspiciously that it's not that jerky footage. It's almost always beautiful, professionally captured footage from something like a Red Epic or a Canon 5D or something like that. And the way that they do that is that they cheat. And I would heartily recommend everyone else do the same. So what they do is they get a professional cameraman to take beautiful footage, obviously minus the virtual reality bits, and then they go into the likes of Adobe After Effects or one of those pieces of software, and they get it to do the 3D tracking, of which all of these pieces of software can do it quite nicely. Then they get that data, that 3D data, which basically works out where the camera was in 3D space, and they feed that into, our case, Unity 3D. And you can basically treat that 3D data as the input to your 3D camera system, so you can basically replay where the camera was in the real world in Unity 3D, and voila. You now have basically your virtual world synced up with your real world. You capture your Unity 3D footage of this 3D camera. So you've got your real world footage, your virtual footage, and then you just compose them together, and that's how you see these beautiful wide open virtual vistas all perfectly synced with the real world. Microsoft and others have really, really expensive ways to do that, but if you want the super, super cheap, reasonably easy way to do it, I can heartily recommend getting After Effects and doing it that way. Okay, that's where things tie up officially. Feel free to tap me on the shoulder if you have any in-depth questions, and I can happily answer them as you see fit. Thank you.